name is getDistance, and today I'll be teaching you how to make a ultrasonic distance detector. Throughout my life, I've always been very interested in engineering. I loved it, and through high school I realized that it was electrical engineering that I had the most passion in, to see how, electronics and electrical systems were all around us, making our lives easier. I wanted to be a part of that. And tonight, I will be teaching you some of the knowledge that I learned, as well as knowledge for you to make your life easier, how to automate your life. I will be covering components that we need and the orientation that they have to be in for it to work. I will be covering the coding required for the microcontroller. I'll be covering what this exact code and circuit can do. And finally, I'll be teaching you how to make it your circuit, how to change it to what application you want it to be used for. Now, starting off, you need a computer to run Arduino IDE. You need an Arduino Uno microcontroller. You need a breadboard, 3 LEDs of different colors, 3 330 ohm resistors, wires and jumper cables, and finally our ultrasonic sensor. Now, I could show you with my hands to build it, but I believe that would be difficult and I would lose you. So, I'll be utilizing a program called Tinkercad. All of the components that I just mentioned are on here. We have our wires, our Arduino Uno, breadboard, 3 LEDs and resistors, and our ultrasonic sensor. Now, we see that our sensor has 4 pins, 2 for power, 1 being ground, which just connects to the negative terminal, and 1 being voltage, which connects to the positive terminal. But we have these 2 right here, which are trigger and echo. These 2 have specific places that they need to be. The trigger is an output sensor that will send out a ultrasonic sound that will bounce off of an object and come back to the sensor, which then the echoPin will take that sound and measure how long it took to hit the wall or object and how long it took to come back in relation to the speed of sound, and will give you a distance. So we connect these to their individual spots on 12 and 11, and then our LEDs follow this orientation, negative to negative, and our positives going through the resistors to their respective spots. Green to 6, yellow to 5, and red to 3. And for our schematic, if this helps you understand it better, here it is. Now, we understand what is required of us to build it physically, but I'll tell you right now, it's not going to work. We need to tell the microcontroller what to do and what to look for. And that is where we bring up Arduino IDE, which is this program. It uses very simplistic coding, and I will go into slight detail. I notated what some prerequisite codes are for, such as what is connected where, such as our red, yellow, and green pins at 3, 5, and 6, our trigger pin at 11, and our echo pin at 12. We see our outputs and inputs. Then, here is where most of the code is in our loop right here. We see that we put this down for the if statement. If the distance that the sensor senses is less than 5 inches, we're going to light up the green LED to maximum power. But if it's greater than 5 inches, but less than 10 inches, we're going to half green and put full power to yellow. Now, this follows through until we get to, in increments of 5, until we get a pure red LED. And the delay is 500 milliseconds for each sound going out and sound being received in. As a refresh, half a second refresh. So, I can show you this, but you're not going to be able to see it in person. Well, good thing I have it in person. If you allow me to adjust my camera for just 1 second, we could see our system right here. As we see here, nothing is in front of the LED or the sensor. But, as you saw right there, if something decides to be placed right here, we see that the yellow pin gets turned on. And then, as we get closer, now it's only the yellow pin, and following code, it should go to the green and yellow, and then now, only the green. Now, you see this, but what can this program specifically be used for? Now, for me, I don't like my door to be opened, and I like it to be shut. So you can use this to have an LED, which will be an indicator without having to look. You know, if you're anywhere in a house, you can have these LEDs connected to the system that could be elsewhere. And you can see, okay, if the door is close to the sensor, it's going to light green, meaning that the door is open. Or if you don't want anything near an oven, you can have this there, and you can see if it's lighting up green. If it's green, then there's something too close to the oven, such as a cat. And if it's red, it's safe. And this seems a little hyper-specific, which it is. But that's where we come to the fourth point, where you make this your own. Let's assume that you wanted to create a mechanical aspect of this. You wanted to add on to a motor with a flag on top as a tiny little desk weight. You could get, as you get closer, it spins faster. As you get further away, it spins slower until it doesn't spin at all. Or it could be more practical uses, such as parking sensors in cars. You could have this open and close a door. These are all examples of how people took this simplistic system of detecting whether something is in front of it or not and changing things in accordance to that. Now, I just showed you how to create the system, the components. I showed you the code, which will be in the description below. I explained what this could be used for, and I explained how you could change it. And what I ask of you is that you do change it. You give this a try. You make your life easier. Thank you. I hope you have a